Hello, everyone. Today, we are going to look at states of matter. But before we do, we have to ask, what is matter? Hopefully, you watched the last video on matter. Matter is anything that has mass and occupies space. Matter is anything that has mass and occupies space. And here are examples of matter. Okay? Here are examples of matter. Okay? And all matter is made up of particles. All matter is made up of particles. So I'd like you to take a blank sheet of paper, draw a particle diagram of solid, liquid, and gases. Draw a particle diagram, pause the video, draw a particle diagram of solids, liquids, and gases. You may not have seen this before, but just think of anything that comes to mind. There's no right or wrong answer. How do you think the particle diagram of solid differs from liquid or gas? You draw them. Pause the video. Hopefully, you drew something like this. If you didn't get it right, just correct it. Correct it. And I want you to watch a video on this.
Arrangement of particles in solids, liquids, and gases. Matter in all three states is made up of particles. In a solid, the particles are closely packed in an ordered arrangement. In a liquid, the particles are loosely arranged but still close together. In a gas, the particles are not arranged in any particular way. The particles that make up matter are constantly in motion. In a solid, the particles do not move around but vibrate about their fixed positions. In a liquid, the particles move around quite fast and slide past each other. In a gas, the particles move around much faster than in a liquid. They move randomly. The particles have empty spaces between them. The spaces contain nothing. In a solid, the particles have small spaces between them. In a liquid, the particles have small spaces between them but larger than in a solid. In a gas, the particles have very big spaces between them compared to solids and liquids. The particles attract each other. In a solid, the forces of attraction between the particles are very strong. These forces hold the particles together. In a liquid, the forces of attraction between the particles are weaker. So, the particles are not held together and move about. In a gas, the forces of attraction are extremely weak. So the particles move about freely. Think about a pure substance such as mercury. It is a solid below -39 degrees Celsius. It is a liquid between -39 degrees Celsius and 357 degrees Celsius. When heated above 357 degrees Celsius, it turns into a gas. The particles that make up mercury when mercury is a gas, a liquid, or a solid are exactly the same. Only the arrangement of the particles, the forces between them, the empty spaces between them, and the speed of the particles are different.
Okay. We've looked at the particle diagrams of solid, liquid, and gas. And when we look at examples of matter, we can see that matter can exist as solid, it can exist as liquid, it can exist as gas. Okay? Now, there are 4 well-known states of matter: solid, liquid, gas, and plasma. But only the first 3 states are common on Earth. So we are focusing on only solid, liquid, and gas. State of matter is a physical property, okay? A given kind of matter has the same chemical makeup and the same chemical properties regardless of state. For example, ice is solid, water is liquid, water vapor is gas. All of them, they still have the same chemical makeup and the same chemical properties. So I want you to pause the video and do this activity. It looks simple and it may not make sense to you, but you want to get some information from this. When you do this, you will understand it more. Okay? So activity 1, put your pencil in a cup. Does the shape of the pencil change after you put it in a cup? Does the volume of the pencil change? These are the questions you'll be answering. And the activity 2, put some liquid, hopefully water, in a cup. Take note of how much space occupied by the water. Then take note of the shape of the water in a cup. Then transfer the water from the cup to another cup with different shape. Does the shape of the water change? Then activity 3, get 2 different shapes of balloon. Blow air into each balloon. Compare the shape of the 2 balloons. Compare the amount of space occupied by the air. Pause the video and do this activity. Now, you will find out that when you put the pencil in the cup, nothing changed. The shape of the pencil, which is solid, doesn't change. The volume doesn't change. So based on that, we can conclude that solids have a definite shape and definite volume and are incompressible. We cannot compress it. From looking at the particle diagram of solid, you find that there's not much space between the particles, then you cannot compress it. The particles are kind of fixed and they're vibrating, okay? So we say solids have a definite shape and definite volume. Then, so solids are defined by the following characteristics. They have definite shape, they're rigid, definite volume, particles vibrate around fixed axis, like as you saw in the video. Then so let's look at the liquid. We look at the 2 different containers, different shapes. This is a beaker, this is graduated cylinder. The volume doesn't change. The volume will remain the same, but the shape, look at the shape. The liquid takes up the shape of the container. Okay? If you look at the particles, there's more space between these particles compared to the particles in solid state. So liquids have no definite shape, takes the shape of its container, has definite volume. Particles are free to move over each other, but are still attracted to each other. Then let's look at gases. Hopefully you're able to use balloon. So I have here in the picture, like you have different shapes of balloon. You find out that these balloons are filled with air, but then they do not have definite shape. They do not have definite volume. There's a lot of space between the particles, so they are moving around and this can be compressed. So we say gases have the following characteristics: no definite shape, no definite volume, particles move in random motion, okay, with no attraction to each other. We can compress it because there's a lot of space between them. Okay, this is what the characteristics of the gas. Remember, we are not discussing plasma here because we are focused on the ones that exist on the Earth. So this is like a little picture that may be able to explain to you this more. Solid, liquid, and gas. You have examples of solid, examples of liquid, examples of gas. Then, I would like you to pause the video and identify the following as solid, liquid, or gases. Picky's micro view and macro view. Okay? Solids, liquids, and gases. Pause the video. Hopefully, these are your answers. A is a gas. It has a lot of space in between. B is solid. C is liquid. D is liquid. E is solid. F is gas. Okay? So how could you show that a gas spreads out to take the volume as well as the shape of its container? Why don't you try to answer this question? How could you show that a gas spreads out to take the volume as well as the shape of its container? Then, the answer is you could pump air into a bicycle tire. This is one example. The tire will become firm all over as air molecules spread out to take the shape of the tire and also to occupy the entire volume of the tire. Okay? This is something we observe every day. Okay, this also enhances the understanding that air is an example of matter and also explains that it's spread out, the molecules spread out to take the shape of the tire. Okay? So pause the video and do these practice questions. Pause the video and do these practice questions. List 4 states of matter. Which states of matter are most common on Earth? Use an example or drawing to demonstrate the characteristics of a solid. Use an example or drawing to demonstrate the characteristics of a liquid. Use an example or drawing to demonstrate the characteristics of a gas. Hopefully, this will, hopefully you got it right. Thank you.